Hello everyone, my name is Detective Viren Mandaogane from Astro Club FC. The word detective is being used as a comic reference to someone who studies science. As you all have seen the topic, I am sure that you are already partially or totally accepting to the fact that the universe is expanding. But today we are gonna question this. This question mark is the birth of our investigation as cosmic detectives. We are going to proceed by a scientific investigation to give birth to a cosmic detective within you. And I'm sure you are going to love it. So, are you ready to solve the mystery? Just like a detective who is finding a missing person or a thing, or for our instance, the reality in the situation. We will first keep this flow in mind. That is, how did he or she go missing in the first place? How much time has elapsed? Then we will gather all the clues and thus solve the mystery, just like these fictional detectives have been doing. First, we will address the real problem because we are not here to think about a person. We are cosmic detectives and we think on universal scales. So, if we were to observe, will we observe the entire universe? Well, just let me correct the question and ask, can we observe the entire universe? This brings us to an even more interesting question, and that is, what exactly is our universe? When we ask this question to one of the famous detectives that ever existed, they would say, our universe is everything we could possibly observe by any conceivable means or be influenced by in any conceivable way. Our universe is a three-dimensional ball centered on Earth. The radius of this circle is how far light could have traveled since the universe began. Nothing can travel faster than the speed of light. No particle, no interaction, and no influence. The distance light could have traveled since the beginning of the time is limited. It's almost 13.7 billion light years, which is the radius of this sphere. We can conceivably observe anything within the circle that defines our universe. We might need a telescope as large as the solar system, but at least it's possible. However, we cannot possibly see the galaxy on the far right. Its light simply had no time to get here. By our definition, that galaxy is not in our universe. Astronomers in another galaxy would say that their universe is the center on their location and contains a different set of galaxies altogether. This brings us to a very peculiar fact about the universe. That is, if we consider our universe to be a sphere, then a sphere would have a center, right? But our universe is a special kind of a sphere in which every point is the center. Yes, every point, and that means even you are the center of the universe. Doesn't that make you feel special already? Next, we learn a very important investigation technique. Let's hear it out. Yeah, most of you got it right. It's the Doppler shift. But today, we're going to understand the Doppler shift in light. As you see in the upper observer, the star is moving away from him. This makes the star appear redder to him. This is called as the redshift. In the second observer, however, the star is moving towards him and it appears to be bluer. This is called as the blue shift. Greater the star's velocity, greater the shifts will be. In standard terminology, for a wavelength, we detectives use the letter Z, where Z plus 1 gives us the expansion factor. To understand this, we have Martha and Gloria looking at each other, standing at a distance x apart. Martha suddenly thinks that she should go 2x distance away from her for all possible reasons, and she moves 2x distance away. This will make a shift, that is, the wavelength would shift 2 times and our expansion factor would thus be equal to 1. So, my fellow detectives, it is time we introduce ourselves to these legends. These legends are going to help us bring in important inputs for our investigation and also have a proper understanding of the case itself. I would like to introduce you to Professor Albert Einstein, Edwin Hubble, and Henrietta Swan Leavitt. We will first go with Professor Albert Einstein and see what he has, if you both don't have a problem. Okay, so let's see what Detective Albert Einstein has to offer. I must tell you, Albert Einstein is one of the most pioneering detectives ever, and his work on understanding the universe will be of great use to us. Einstein held an investigation on the gravitational forces. He wanted to understand what is the mechanism behind the working of gravity, as to why this sun or this earth is moving around the sun. What is the mechanism behind it? On further investigation, in 1915 he gave to us the general theory of relativity in a beautiful paper. If you want to really understand this theory, it is really important that you feel it. And for that, we are going to perform a thought experiment. Consider a physicist in an elevator at 100th floor and imagine a cable suddenly breaks, dropping the elevator, while the poor soul haplessly falls towards a sudden stop. He sees no evidence of gravity. Naturally, our physicist will be eager to perform numerous quick experiments. He grabs his keys, extends his arm, and releases them. The keys seem to hang motionlessly in space. Then he places his keys on the ceiling and watches as they stay there. And then, oh, Einstein called this realization the happiest moment. To Einstein, this insight meant free fall is the simplest fall of natural state of motion. It is the floor that makes us deal with gravity by preventing us from falling. The floor makes physics seem more complicated than it really is. Einstein developed this generalization into a fundamental principle of general relativity, that is, the equivalence principle, which states locally gravity is equivalent to uniform acceleration, and here locally means small region in space. Einstein's theory of general relativity is embodied in his field equations. It is said that beautiful equations are a poetry in physics. Well, this equation is an anthology on its own. Here, G is called as the Einstein tensor and represents the curvature of spacetime. T is called as the energy tensor and represents the entirety of all forms of energy, mass, and pressure. Tensors are mathematical entities that conform to the rules of special relativity and allow us to properly describe physical quantities such as position, velocity, and electromagnetic fields. Einstein showed that equations like this equation written in tensors in four-dimensional curved spacetime, or what we call as the properly written, are valid for all the observers regardless of their velocity, acceleration, or location in gravitational fields. One property of tensor equation shown above is that it represents 16 separate but related equations. Thus, I called it an anthology on its own. We must ask our detective Einstein that how did he picture this reality, and he answers like this. Well, obviously the first part is completely false, but the second part is where we stand right now, because if you have been patient enough to listen till now, you might be thinking like Einstein too. Well, after that piece of motivation, you will now ask me, how was Einstein's idea even useful to us in any way? Well, it will be useful in all the possible ways. When our fellow detective published his paper, everyone believed that the universe was static. But if universe is an assembly of these gravitating bodies that we see all around, how can we accept it to be static at all? This means that the universe must be either contracting or expanding. Einstein even then thought that the universe must be static, and he included another constant into his equation so as to fit his model for a static universe. And this is where our next two detectives come in. It is important that you pay special attention to the work of these detectives, as they were the ones who dared to observe the entire universe. It was during this time when, like us, detectives questioned how big the universe was, to which they would confidently answer, the early generations believed that Milky Way was all that existed in our universe. But our detectives, however, found something wrong, something missing in the picture. And thus, Hubble, in his findings, with the help of Leavitt, proved that Andromeda is not just a smudge in space, but a galaxy on its own, comparable to the Milky Way. Hubble and Leavitt made a revolutionary discovery. It was the first time after the discovery of Andromeda as a galaxy on its own that people and the detectives could think of something extragalactic. Rita Swan Leavitt, a brave woman detective who overcame deafness and male chauvinism to become the first famous female American astronomer. It was her study on Cepheid variables that helped Hubble pass his investigations on the Andromeda. Cepheid variables obey a special relationship. The period of Cepheid, that is, how long its brightness takes to cycle up and down, is directly related to the maximum energy output. So, by measuring how much Cepheid's light reaches Earth, And using Leavitt's relationships, astronomers can now determine how far away a star is. And this was huge. This allowed us to measure galactic distances. Our detective Hubble used Leavitt's law to calculate distances to many other CFIDs that were present in different galaxies, and he also calculated their velocities by using the Doppler, or rather the redshift method. Let us try and see what Hubble tried to measure. What he did was he arranged all the galaxies in a descending order of their relative velocities with respect to us. And then he arranged them, or rather compared them to the relative distance from, as in how much far away they were from us. And to his astonishment, he found this relation. What can you find from this relation? You must pause the video and think. Well, let's see if you got it right. Let's ask our fellow detective, Hubble. Well, Mr. Hubble, what do you concur from these graphs? He says, well, from the graphs that I have studied, it is clear that the velocity with which the galaxies are moving away is proportional to the distance. Well, if you thought that, you might as well have rediscovered what is now called as the Hubble's law. If you are really interested, this is how Hubble's plot looked like. You see, the Hubble's law should not be interpreted as just an equation that the galaxies were following. There must be a mechanism that establishes the velocity of each galaxy. If you consider that this dance that these galaxies are doing around, you as a cosmic detective must ask, what is the mechanism of this dance? And if there is a dance, what is choreographing it? This may sound crazy, but let us ask our very famous fictional detective, Sherlock Holmes, if he can help us. Well, Sherlock, we detectives are stopped. We do not know what is going to happen ahead. Can you give us some word of advice? Oh, not this. This is typical Sherlock being Sherlock. Any more advice you could give? Ah, that is what we need. Well, let us try and look at this in another perspective. In this animation, you are seeing that the galaxies are moving away. But if you look at it very closely, what do you see? You see that it is the space. It is the space that is expanding. The Hubble's law was shouting it out loud from the very beginning, and we did not see it. And so thus it is revealed. The space in the universe is expanding. Our question mark, our very investigation is solved. But wait, something seems wrong. We are saying that space is expanding. And that brings out a very peculiar doubt. Isn't space a whole lot of nothing? How can space even expand? You can imagine the universe as a balloon with multiple marks on it. If you inflate this balloon, obviously you will see that these marks that you draw are going to stretch apart as the balloon is becoming bigger and bigger. This is a similar case that happens in our universe. where if you see in this animation, the galaxies will represent the dots that you have put on the balloon, and the space itself is being expanded. This is a really good animation, also showing you the shifts in wavelength as the universe is expanding, which we all observed, or rather, which Hubble observed. But then I have one more doubt lingering in my mind, and that would be that if space is moving, then how can we say that this is Doppler redshift, as there is no motion of either observer or the source? This is a really important doubt. Most of us usually get confused between a Doppler redshift, or rather Doppler shifts, and what we call as the cosmological redshift. The thing that is happening in our universe is not a Doppler shift. The thing, or rather how Hubble measured his redshift, was also not a Doppler shift, because there is no actual movement between the source and the observer. It is the space between them that is being expanded, and therefore it is called as cosmological redshift. What we observe here, I will repeat, is not Doppler shift. It is called as cosmological redshift. So, our investigation states that our universe is expanding. Faced with the proof that the universe wasn't static, Einstein renounced his idea of the static universe. As Einstein said, anyone who has never made a mistake has never tried anything new. Einstein called this the greatest blunder of his life. Einstein's blunder don't diminish his phenomenal impact on physics. In fact, Einstein was world MVP, the world's most valuable physicist. This brings us to a very important question, and that is, what is the not expanding? Well, our Milky Way galaxy, for instance, is not expanding. The solar system is not expanding. And we humans, for all cosmic reasons, are not expanding. That is because the expansion forces are far more weaker than the forces that are keeping us intact, helping us not to expand. Coming to the modern times, our cosmic detectives have big telescopes to observe the night sky. Hubble has found something called as a type 1a supernova that was 7 times farther away and opened our eyes to a dramatic and new understanding of the universe. It gave us many models in which the rate of expansion of our universe was considered. And according to these models, the fate of the universe was also being modeled. This is a question for the new generation of cosmic detectives. Latest detectives are working tirelessly to understand what will be the fate of our universe and how can we define this mysterious dark matter and dark energy. At the conclusion of many classical mysteries, the detective gathers all the principal characters in a parlor and announces the results of his or her investigation. In our detective story, of course, we are not investigating a crime, but an act of creation and the mystery is all the deeper. It may not lend itself to a simple wrapper, but it will take, however, many detectives to solve. Even then, can it really be solved completely? Are there some things in the cosmos that are simply unknowable? Could we ever know precisely why the universe came into existence when it did? The motive is often the most difficult thing for a detective to establish. Regardless of whether or not we finally deduce the why of the universe, we have come within a minute of a fraction of a second to understand the how. And that may be enough to allow us to consider the case closed for now, or at any rate, not completely unsolved. Most importantly, though, the inference of our investigation will make us see the world and ourselves in a radically different way. And that is what I can promise. Well, hello, fellow detectives. If you liked our investigation and you want to enjoy furthermore, please like, share, and subscribe to our channel. Thank you.